Hey, you're listening to Buzzkill. I'm Teresa Katsourelis.
Flowers from the wild onion. Oh, you see that native bee that just went up to the red flower?
Oh, I see him. Oh my God, he's tiny. Oh my God.
I'm crouched over in a lush urban farm with Una Valle and Jacob Sandoval.
Do you want to interview him?
Yes, obviously. Hello, good sir.
There's so much beauty around here.
We're watching this native bee the size of a small fly wiggle its thorax and burrow into some hot lips flowers. Yes, that's actually what they're called.
This red little flower, I see some sweet nectar in there. Ooh, can't wait to tell my friends.
I came here to witness wild bees in action and to understand the nuances of our dependence on pollinators. And while I wasn't expecting it, part of that, apparently, looks like handing over the mic to the bees and the flowers.
I'm the voice of the flower, and I'm so happy you came to visit me.
You know, just two urban farmers voice acting pollination.
Try this one. We've got extra nectar in this little bucket. You're
Thank
so
you.
Thoughtful and considerate.
Oh, you two. I believe we bring out the best in one another.
What we're really talking about here is plant sex. I just want to make that super clear. Most flowering plants have both male and female reproductive parts.
Could you just buzz a little more? I'm really wanting my pollen to reach my stigma.
The pistil contains the ovules, or the plant equivalent of eggs. The stamen distributes pollen, which is kind of a plant's equivalent to sperm. To procreate, these male and female reproductive organs have to touch each other. And in most cases, flowering plants can't move around and make that happen on their own. That's where the birds and the bees come in. As pollinators perch on a flower to eat pollen, or flower nectar, the pollen sticks to their bodies. When they fly along to the next flower, they bring that pollen along with them. And they deposit it onto the female parts of that flower. This allows the plant to procreate. Certain bees are particularly great at this.
Yeah. So now I got the booty vibrating.
They vibrate their thoraxes, releasing pollen from the plant. It's kind of erotic.
So now we're really doing this dance together, and it's making for a very juicy time. Having a good time here. I am enthralled. Woo! I'm really feeling myself. This is great.
And when they fly along to the next flower, they bring some of that pollen along with them. This allows the plant to procreate. All of this is happening within a half-acre community and urban farm known as Canonical Farms. A few decades ago, some homeowners in this part of Oakland, California, knocked down the fences between their backyards. Their bungalows surround jungly fig trees and prehistoric-looking ferns. The farm itself is tucked back from apartment buildings and car mechanics shops.
We get a lot of our greens and our medicinals and our fruits from here.
A group of indigenous Mayan women is growing squash and corn in the planter boxes.
Good morning. Hello.
A couple of folks here have sheep. The mariachis down the street have an altar to the Virgin Mary in their front yard and a black sheep in the back. Una and Jacob are two of the roughly 40 people that live here.
These little white moths that come through to the wild onion, I like to think of them as flapping pillows.
Una calls herself the pollinator guardian. And under Una's care, Canonical Farms is crawling with pollinators. There are black bumblebees in the plum blossoms and little white moths in the wild onion. A lot of the food this community eats is grown sustainably right here, which is important to Una because she wasn't always the community organizer she is now. She was trained at Cornell University's ag school, one of the top ag programs in the US, and she thought commercial ag was the way to go.
I learned about pesticide application and all that sort of thing and got indoctrinated with this mentality that it is our responsibility to feed the world through these ever quote unquote improving technologies. And I think after a couple years of like really being immersed in those commercial systems, my heart just broke. I couldn't take it anymore.
When you think about where our food comes from, what kind of images pop into your head? The bucolic fields of a family-owned operation, or a hyper-local organic farmer, kind of like Una? Well, these days, most of the nation's agricultural output is actually produced by large, privately owned family companies or multinational corporations. Welcome to the world of big ag. This food system's industrial. It relies on pesticides, synthetic fertilizers, and other chemicals. It's already gobbled up about half of all the habitable land on the planet. This system is the #1 cause of the biodiversity crisis. And pollinators are particularly vulnerable.
These things are just they're not sustainable in any way. They're not ethical in any way. And our food system is still built off of that model.
Yep, I know. It's a buzzkill. But one scientist's been tracking this for years. In Mead, Nebraska, where colony after colony of honeybees signaled that something mysterious was happening in the community. In episode 1, we asked which bees should we actually be saving? And now we're going to explore one of the things that's been killing them off. From the Food and Environment Reporting Network, this is Buzzkill, episode 2, The Mystery of the Dead Bees. Here's reporter Dan Charles.
So I zip up here first?
I'm trying to get into a bee suit for protection. Judy Woo Smart is showing me how.
Actually, if you leave that on, it keeps the hood from...
Oh, okay.
It's actually...
Judy runs the bee lab at the University of Nebraska-Lincoln. We're in the backyard of a little one-story house on a research farm that the university runs about half an hour north of the main campus. I see 3 beehives.
That's a lot of bees, though.
Yeah.
A patch of wildflowers, a line of trees. And beyond that, miles and miles of cornfields.
It's a nice day, too, so the bees should be relatively nice.
They're happier on a nice day?
Yes. Aggression could be a sign of something going on or going wrong with the colony. And so when colonies are dying, they tend to be a little bit more aggressive or spicy.
Judy's wearing a big hat with a giant honeybee made of yellow and black yarn embroidered on the brim. It's cute. Judy's small, unpretentious. But when it comes to protecting these honeybees, she does not back down. She pries the top off of one hive and peers inside.
Actually, they're not producing very much honey at all.
They're not producing that much honey, huh?
Yeah, they're alive, but they're not to peak health.
Judy's looking for patterns in the waxy cells, looking for clues.
In a healthy colony, you would see a solid brood pattern. And here we see a spotty brood pattern, meaning bees have an incredible ability to sense something is wrong with their larvae.
Watching her, I get the sense that Judy's looking for problems. She's hypersensitive to anything that might be going wrong here. Because in fact, so much has gone wrong for bees in this exact spot over the past few years. About 8 years ago, Judy set up her very first beehives here. But when she came back to check on them,
bees just spilling out of the hives and dying.
Piles of dead bees in front of the hives.
Bees shaking and trembling, tongues sticking out. But inside the hive, you still have bees that are trying to forage for food, that are trying to rear babies. The queen is still trying to lay. But at the same time, the adults are dying out in the front.
This was a disaster for Judy, too. This was her first real academic job. To keep it, to succeed, she had to prove herself. These bees were her research program. They had to survive.
Your heart just sinks, and it's just, oh no, what is going on with this colony? Where do we start?
Judy didn't realize it at the time, but she had stumbled onto a scandal. One that implicated some of the biggest companies in American agriculture. What was going on here was outrageous, shocking, but it was also somehow ordinary. It grew out of farming practices that are normal, conventional. The vast fields covered with just a few crops, like corn and soybeans, protected from insect pests and weeds with cheap and convenient chemicals, in the process, killing all vulnerable creatures like bees and other pollinators. This was our biodiversity crisis in concentrated form. Judy looked at her dying bees and put on her detective hat. This was a mystery, begging to be solved. And there was one obvious clue.
But you know that these are classic signs of a pesticide kill.
So you thought pesticides right away?
I did, and part of that is because all the colonies were being impacted. It wasn't just one colony.
This location here, every location?
Everything was within a couple of miles of one another, and they were all exhibiting the same traits, where bees just kind of looked very sick and they were dying in an abnormal rate.
They tested the dead bees, and they found traces of various fungicides and weed killers, but not at concentrations high enough to cause a bee massacre.
So, unfortunately, it was extremely frustrating to get these results back and see really no red flags.
So the testing did not reveal anything right away?
No, not at all. I mean,
it was 2017. The next spring, with flowers blooming, she tried again. Brought fresh colonies of bees out here, trying to get her research off the ground finally.
We had losses very similar to what we saw the previous year.
The same thing happened. The bees died.
Where there was just piles of bees dying from the colony week after week until they just were completely depopulated.
Judy started thinking about one class of pesticides in particular. They're called neonicotinoids, neonics for short. She'd studied them in grad school. They're extremely toxic to bees and many other insects, and they're commonly used with crops like corn and soybeans, the most widely grown foods in the country. Judy knew that neonics were everywhere in the cornfields all around here, because these days, almost every kernel of corn that farmers plant as seed comes covered with neonics. And when I say seed, we're not talking little seed packets like you might get for your garden.
This is the location and size of the corn belt at about the time your grandparents were born. Although the location and size hasn't changed much since.
American farming operates on a huge scale. Corn alone grows on 90 million acres. That's an area the size of New York, Pennsylvania, and Ohio combined. That corn shows up in all kinds of places. It's the grain that feeds the cattle that satisfy our appetites for steaks and burgers. It goes into the corn syrup that sweetens our food and soft drinks. It's the source of the ethanol that's 10% of the gasoline that powers our cars.
Corn is the key ingredient in the alternative fuel ethanol. It is a gold rush everyone wants to get in on.
So the business of growing and selling the seed for these mega crops is also huge. It's dominated by big companies like Syngenta and Corteva and Bayer.
At Bayer, we know possibility grows from the seed of a vision. Rural communities aren't just farms, but all the people they feed. That's why Bayer partners with farmers to protect those ideas.
American farmers plant about 1 million tons of corn seed every spring, trillions of individual kernels. And back in Meade, Nebraska, Judy Wu Smart had heard about cases where the neonic coating on those corn seeds rubbed off during planting, blew into the air, killed a bunch of bees. So the next year, she waited until the planting season was over to avoid that dust. Then she set up her colonies, but again, week after week, the bees died. If you're counting, that's 3 straight years.
Are you thinking I'm doing something wrong here?
Well, it was certainly frustrating as a new faculty, a new professor. You can't start a program if you can't keep bees alive.
Now, Judy didn't know this, but right around this time, about 5 miles north of her and her dead bees, something bad was happening to a dog, a chocolate lab named Buddy. I tracked down his owners, Keating and Paula Dias.
I'm sorry I'm a little early.
Oh, no, you're fine.
I was worried about being late.
Oh, no, come on in.
Keating and Paula are dog people. They bought this house when it was a ramshackle fixer-upper. They liked it because it came with land where they could walk their dogs, like Buddy. But one spring day, Buddy was in bad shape.
He seemed like he was deaf and incoherent, stumbled around, couldn't motivate very well. Took him to the vet. They actually had to give a sub-Q intravenous as far as fluid because he was dehydrated. He wasn't drinking. He wasn't doing anything.
Then another one of their dogs got sick, Athena. Same symptoms. And Paula Dias remembered something. There'd been big trucks driving down a road practically every day, carrying some sort of sloppy, smelly material, dumping it in fields right nearby.
I mean, I thought at first when they spread it on the field that it was manure. And the dogs were, of course, entranced by the odor, and I wasn't overly worried at first. I think that it was our neighbor who farms nearby us who told us that in passing, he said, I wouldn't let your dogs eat that.
The farmer knew that the trucks were coming from an ethanol factory on the other side of town. Ethanol factories are pretty common in the Midwest. A third of the country's entire harvest of corn gets trucked straight to those factories. They're giant distilleries. They take the corn, grind it up, and ferment it to produce alcohol that gets mixed into practically all the gasoline that we put in our cars. What's left over from this process, a slushy mash called wet cake, normally goes into cattle feed. That's what those trucks were hauling past Paula Dias's house, wet cake, except this factory's waste couldn't be fed to cattle. It would have been illegal. This ethanol factory was owned by a company called Alt-N, as in alternative energy, fuel from corn. And instead of processing regular corn, Alt-N was using seed corn, the stuff that was pre-treated with neonics. You could tell because the seeds were covered with bright-colored dye, often green, that served as a kind of don't eat me warning. You see, seed companies wanted to get rid of this inventory because it was old, past its sell-by date. And Alt-N had the bright idea of using this free corn to make ethanol. It offered what it called a green recycling program for treated seed, and the seed companies loved it. Alt-N was processing thousands of truckloads of treated seed each year. 98% of all the discarded seed corn in the country, according to Alt-N's promotional materials, was going to this one plant. Just one problem. The byproduct from fermenting treated seed, that wet cake, can't be fed to cattle. It's against the law. If it contains pesticide residues, it isn't supposed to be spread on fields either. But that's what Alt-N was doing.
It was painful for us with our pets and our family to not know how to address the situation.
Now, Paula Dias once worked for a big seed company. She knew what treated seeds were, what kind of chemicals were on them. So she called up Alt-N.
And I told them that we had sick dogs, and I'm just trying to treat our dogs. So in order to treat our dogs, I need to know what might be in the material that you're spreading that would be causing them to be ill.
And what'd they say?
They're like, oh, there's nothing in there anymore. That would have all come off during the ethanol process. All the chemicals would have been gone, they said.
That's what they told you?
Yeah. Yeah. And then they also told me that it could have just been some residual ethanol in the product that was causing the dogs, because dogs can't metabolize alcohol either, so it could have caused them to be ill, but not in the way that they were exhibiting their symptoms.
Basically said your dog's drunk.
Yeah.
Paula didn't believe this. She has a master's degree in animal science, works for a big pharmaceutical company, and this became her mystery to solve, just like Judy's. She went out and collected some of that suspicious wet cake, and she had a lab at Iowa State University test it for pesticides. The results came back, and yeah, there was a list of fungicides and a neonicotinoid insecticide. At that point, Paula sent a long email to Nebraska's Department of Environmental Quality and Department of Agriculture, laid all this out. But the state regulators seemed weirdly uninterested. One official told her that Alt-N didn't actually appear to be violating any state laws, which Nebraska could enforce. Another one pointed out that her tests just showed the presence of pesticides. He said he'd need to know how much was there.
And I said, but isn't this enough that maybe you guys should want to test it now? Because these chemicals were bioaccumulative and they were harmful to aquatic life. And yet, that was well known, well documented, and nobody at the Department of Ag wanted to know how much was there.
Buddy and Athena did survive, and Paula's complaints actually got things moving in the bureaucracy. State officials started to demand some answers from Alt-N. Eventually, they carried out their own tests of the plant's waste. They discovered that a single ounce of some of the wet cake contained enough neonics to kill hundreds of thousands of bees on contact. And Alt-N had accumulated thousands of tons of the stuff over the course of years, with little to no oversight. The state then ordered Alt-N to stop spreading it on fields, but Alt-N fought that order, said it was unjustified. The thing is, State officials never announced any of this. We only know it now thanks to documents that the state released much later. They never told the plant's neighbors, like the diocese, what Alt-N was doing and what the risks might be. And Judy Wu Smart? She had no idea. Nobody else seemed to either.
I would talk to everybody I could to try to figure out what is a better way of trying to document what is happening to these hives.
In the spring of 2020, she was puzzling over some very weird lab results. They showed neonics in milkweed plants near her beehives.
And at levels at like 3,000 to 5,000 parts per billion, which is just unheard of in terms of our literature.
The weirdest thing was, the really high levels were in milkweeds growing alongside streams and drainage ditches, not the ones closest to fields where neonics are actually used. Judy was confused. Was somebody out there spraying neonics around drainage ditches? Maybe to kill mosquitoes?
So that's when I reached out to the Department of Ag and to EPA folks to try to figure out, is there any city spraying or mosquito abatement program that's happening that we're just not aware of?
On a Wednesday morning in May, at 11:20 in the morning, she gets an email from a top pesticide regulator at the Nebraska Department of Agriculture.
This is at the point, just a mile north of our locations, is this ethanol company.
The Alt-N plant. The email goes on to explain how the plant was processing pesticide-treated seed corn, resulting in huge piles of wet cake, chock full of neonics. This was a whole year after the state had ordered Alt-N to stop spreading its waste on farmers' fields. Judy had a hard time taking all this in. She had to put the pieces together in her mind.
I went on a drive.
North from Lincoln, past the research farm with her beehives, to the small waterways where she detected neonics in the milkweed plants.
And I just tried to follow those waterways to see where they would lead.
And indeed, they lead to the Alt-N site. And then she sees along the side of the road a pile of ghostly green sludge, the wet cake.
And that's when it kind of hit me like, oh my goodness, how could have gotten it? It's just speechless, really. Not only was the odor and the smell so pungent you could barely breathe, but just seeing that much of that pesticide-loaded waste with rainwater puddling around it, with, just plants blooming around it, it just, I don't know. It's a feeling of just complete disgust, disappointment, surprise, just complete, like, how could this have happened?
So Judy started calling people up, journalists, local officials, trying to spread the word about Alt-N and what it was doing.
I used to love the rain, and after this experience, every time it rains, it reminds me of a new wave of chemicals.
Other local environmentalists joined her. They got the newspaper The Guardian to run a long story, which provoked a storm of attention and finally action. In February of 2021, Nebraska's environmental regulators shut Alt-N down. Its waste ponds, giant rectangular pools filled with pesticide-laced liquid, were over capacity. A few days later,
we start tonight with some breaking news out of Meade, Nebraska.
A frozen pipe at the plant burst.
There's a leak of wastewater from a container at the Alt-N ethanol plant in Saunders County.
The waste contaminated miles of drainage ditches and streams.
All right, relatives, we're done here. I believe this is 9th, County Road 9 and J.
Local environmental activist Mahmoud Fatil went out there in the middle of the night and started live streaming.
And this is the wastewater. It stinks. It smells absolutely putrid. Again, it smells like rotten fish guts.
This was pretty much the end of Alt-N. The company's executives abandoned the site. I reached out to some of them for an interview. They said no thanks or didn't respond. Some of the companies that sent all those neonic-coated seeds in the first place agreed to step in and clean up the mess. I contacted them as well, and two of them, Bayer and Syngenta, got back to me. Bayer wrote that shipping discarded seed corn to Alt-N seemed like a good alternative at the time. Both companies accused Alt-N of lying about what it was doing and violating contracts that required it to comply with all environmental laws. So, mystery solved. Neonics in the waste from the Alt-N plant were killing Judy's bees and poisoning Paula's dogs. But it got a lot of people thinking about a much bigger question. There are neonic-treated seeds planted on tens of millions of acres of farmland every year. What impact are all those neonics having? Could they be part of the reason why pollinators are disappearing? About 15 years ago, Maggie Douglas stumbled across neonics, and they changed her life.
I ended up studying them quite accidentally.
I met Maggie in her office at Dickinson College in Carlisle, Pennsylvania. She's got a display case with dead beetles impaled on little needles, posters on the walls about how to deal with insect pests in an eco-friendly way. This all started back in grad school, 2009, 2010. She was looking for a research topic, and her advisor said, "You know what farmers would really, really love? Some way to control slugs. Slugs are chowing down on their newly sprouted corn or soybean plants. Why don't you look for some natural, chemical-free solution? Some insect that would eat the slugs."
And so initially, I wanted to do some really simple experiments to just bring the slugs into the lab, create little kind of terrariums with some soybeans growing in there, some slugs in there, and then introduce different predators and see whether the predators would A, eat the slugs, and B, protect the plants.
Maggie set it all up. The slugs, some beetles she was auditioning for the role of slug predator, some freshly sprouted soybean seeds.
And I came back a couple days later, and most of the predators were dead. Remember, again, I'm a master's student. I'm quite early in this whole process. So my first thought is, clearly I did something wrong, right? I made some kind of mistake. What did I do here? And so I started thinking through what are the things that might have happened here, and then realized, actually those seeds that I planted in these little terrariums, well, they were like bright orange.
They were standard commercial seeds, coated in neonics. Maggie hadn't noticed. The same way the state regulators in Nebraska didn't really react when they saw truckloads of brightly dyed corn go into the Alt-N plant. But now, Maggie wondered, were the treatments on those seeds powerful enough to kill insects that you actually want in your fields? She tested the idea with an outdoor experiment in regular soybean fields. Some fields were planted without the neonic seed treatment. Some were planted with the neonic seed treatment.
And what we found was that where the seed treatment was used, we found more slugs, more slug damage to the plants, actually fewer soybean plants.
Something totally wild was happening. Slugs were feeding on the soybean sprouts, ingesting neonics, and they were fine. Slugs are pretty much immune to neonics because they're mollusks, not insects. But when the beetles, the good guys in this story, tried to eat those destructive slugs and protect the soybean plants, the beetles got a fatal dose of neonics. That's why Maggie was seeing more slug damage to the soybean seedlings.
And actually lower yield.
Smaller harvests, exactly the opposite of what a farmer wants. And Maggie says the thing that she finds kind of shocking about this is that nobody seemed to have looked for this kind of effect before. It's like neonics and their ecological impact had been flying under the radar, even though they'd been on the market since the 1990s, and they'd taken farming by storm.
The curve of neonicotinoids occurred so quickly, right? It was like they didn't exist, and then a few years later, they were everywhere in corn.
That's an important clue to understanding the neonic phenomenon in American food production, Maggie says. Farmers paid for these chemicals, but they weren't the ones driving this.
In a very literal sense, farmers are not applying these products. Seed dealers are applying these products. Seed companies are applying these products. They have become the default option.
Companies apply neonics to corn seed in centralized processing plants. The way car companies install tires on cars, right on the assembly line. Neonics just come standard. Which, by the way, is why seed companies had to send all that excess inventory to Alt-N. It was all pre-treated with neonics. In some other crops like soybeans and wheat, farmers do have a choice to treat the seed or not. Because there, it usually happens at a local seed dealer. But even there, neonics are often the default option. And what really, really bothers Maggie is it usually means that neonics are going into the ground all across the country, whether they're actually needed or not.
The pattern of neonic seed treatment use in the United States today is really a 1950s pre-silent spring, pre-integrated pest management approach. It says, let's take this incredibly powerful insecticide and use it on, in the case of corn, virtually every single acre, regardless of what pest might be out there.
Pretty much everybody agrees we had to ditch that approach. It's destructive to the environment. So why do seed companies do this? I called up Mac Earhart, president of Albert Lee Seeds in Albert Lee, Minnesota. He grew up in this business, watched it change, and I asked him, do seed companies have to put neonics on every corn seed?
I think the answer is no. We don't.
But they do it, he says, because of competition. To make money, every seed company has to prove it's got something better.
What you've had in the seed industry, my opinion anyhow, is an arms race to maximize seed protection as you can in order to maximize the performance of the seed that you sell that farmer so that that farmer buys seed from you again next year.
And farmers, for their part, are desperate for anything that lets them sleep better at night. Anything that promises to protect their enormous investments.
So you're a farmer, you've got tractors that are worth $500,000 a piece, a combine that's worth $1 million. You've got land that's worth $10,000 to $20,000 an acre, and you got one chance to get it right. So even though 9 out of 10 years you might not need that insecticide, well, what if it happens to be that year where western bean cutworm is a problem, right? Or whatever the insect pest that you're worried about. And I think that's the primary driver here. Is it's a sort of an insurance program, if you will.
I heard exactly the same thing from Brian Waddle, a farmer in Nebraska. I caught up to him while he was taking a break from baling hay on a field just south of the Platte River.
It's really cheap insurance, and it's like an extra insurance in our back pocket. We put the seed out there hoping for the best, and the good Lord will hopefully take care of the rest, but we got to try and do as much as we can to help that seed out.
It costs so little. Why not use it? There's no harm in it, right? That's the big question. And the answer has been emerging in bits and pieces over many years. It seems there is some harm in it. Here's the thing about neonics. They don't stay put. They do hang around in the soil, but they can dissolve in water. They can flow into nearby streams. Neonics on seeds are taken up by growing plants. They show up in a plant's flowers, and it's pollen, which of course is a pollinator's dinner table. So a small army of researchers is trying to figure out what all this means for all kinds of living creatures, especially pollinators. And Maggie Douglas is one of them.
The neonicotinoid research literature at this point is vast. It's funny, on my computer right now I have like 40 tabs up because I was just trying to pull up, many of the kind of key studies on this question.
Is it still open?
Yeah.
Here,
let's
look at your tabs.
Okay, look at my tabs? Yeah. Okay, let's see. Oh yeah, this is a good one. This is one of the first. If we want to talk about bees.
Okay, let's talk about bees.
This is one of the most impactful and important studies that's been done on neonicotinoids in bees. It was done
2015.
Yeah, published in Nature.
The scientists monitored honeybees, bumblebees, and another kind of wild bee called mason bees in different areas filled with fields of a crop called oilseed rape. And when the bees gathered pollen from crops that were grown from treated seeds, they had a harder time thriving and reproducing. Remember Judy's honeybees with their spotty brood pattern? This was especially true of the wild bees, the mason bees and the bumblebees.
And that's actually a pattern that is quite consistent across much of the neonicotinoid literature, that some of the strongest negative effects that we see are on bumblebees in particular.
Maggie pulls up one paper after another. There are studies in the lab, in the field, with different species of bees. Some studies didn't show any harm from neonics, but many more did.
When those things all point in the same direction, that makes me feel more confident that there's really something going on there.
It's been enough for some governments to step in and try to pull the plug on neonics.
London's Parliament Square was abuzz Friday with people dressed as beekeepers and even bees.
Without the bees, we'd have to hand pollinate.
At one point, the activists swarmed around the British Prime Minister's home, lobbying for a yes vote Monday for the ban on a pesticide called neonicotinoides, believed harmful to bees.
The European Union has banned most ways that they're used.
Outside the European Commission, 15 of the EU's 27 members voted yes. paving the way for...
In Canada, the provinces of Ontario and Quebec passed a law that requires farmers to show evidence they actually have an insect problem before they can buy a neonic-treated seed. The state of New York just adopted a law that bans neonic seed treatments in corn, soybeans, and wheat starting in 2027. But there is a loophole big enough to drive one of those million-dollar tractors through. State officials can lift the ban if they decide it would hurt farmers. All in all, the U.S. has done very little. The U.S. EPA says it has some sort of draft rules on neonics in the works, but so far it hasn't released any details. The seed companies have been fighting any further restrictions. Here's Pat Miller, a top lobbyist for the American Seed Trade Association, talking to a group of state pesticide regulators in 2022.
I was asked at a recent meeting by one of our upcoming leaders, and they were asking what in the states I considered to be our top priority, the top three priorities, and I had to say that it was treated seed, and treated seed.
Miller praised neonics, claimed they're actually environmentally friendly. He said it's either use them on seeds or spray more dangerous insecticides all over the fields later.
If neonics were not available, 1 pound of neonics would be replaced with nearly 5 pounds of other insecticides, resulting in an increase in application rate per acre of 375% and hundreds of millions of dollars in additional cost to farmers.
Maggie Douglas says, okay, there are some occasions when neonics are helpful to control particular pests. But the way we're using them now, total overkill.
You know, I've watched farmers stop using them and still be successful and still be able to grow crops. And so this idea that this is some like essential input, I don't think that's true. And that's good news, because wouldn't it be so challenging if these were like essential, you know, tools for agriculture and they were having these non-target harms? Well, it turns out that doesn't seem to be the case.
The Alta-N plant is a giant cleanup job now. The seed companies that took it on hired a contractor, a company called Newfields. It deals with industrial waste cleanups all over the world. Newfields shipped all the unprocessed pesticide-coated seed to an incinerator in Tulsa, Oklahoma, sprayed the 100,000-ton pile of wet cake with a quick-drying plaster called Posi-Shell to keep the rain from washing it away. They're working on a disposal plan, mixing it with a clay-like powder to make it thicker so they can haul it to a landfill. But it's hard to imagine this site will ever be completely clean. A couple of miles south of here, Judy Wu Smart has her beehives set up again. When she first came here to study bees, her plan was to look at how colonies respond to different features in the landscape, to plots of pollinator-friendly flowers or lines of trees separating them from cornfields. But now, she's treating this area as a kind of open-air laboratory to study the leftover neonics from the Alta-N plant, how they migrate, how they affect bees and other wildlife.
You know, this is one example of a horrendous pollution caused by these products, but it opens up all of these conversations about whether or not we are monitoring the right things. You know, why do we not have a system in place to see if they are contaminating vegetation, plants, and wildflowers that they're not supposed to be in? Neonics are showing up in wetlands that are not near cropping fields. They're showing up in the spleens of deers. You know, they're showing up, from our research here, in the eggs of birds.
So the new project is trying to figure out what impact those chemicals might be having. She and some colleagues are taking samples of vegetation, monitoring creatures in the soil, red-winged blackbirds, and of course her bees.
We also have weight scales on some of these colonies to see how much weight they gain each season.
It's like the honeybees are living lab instruments, picking up clues about what's happening in the surrounding environment.
So when we design experiments, we're not just looking for ways to better manage them for their health, but also what can we learn from them as a bioindicator model system. Yeah, and so
a bioindicator model system. So that's what.
Yeah.
That's the canary in the coal mine thing.
That's the canary in the coal mine thing.
That's scientific speak for canary in the coal mine.
Yeah, exactly. And
they're the early warning. They're telling us that the drive to grow more food can wipe out other living creatures, including the tiny ones that do the job of pollination, producing so much of the food we need.
This episode was reported by Dan Charles and produced by Buzzkill senior producer Alyssa Jong Perry. The music arrangement and audio engineering were done by Sound Sanctuary. Naomi Barr is our fact checker. And a big special thanks to Lisa Zaleski, Amy Sullivan, Dave McLaughlin, Ted Genoways, and Switchyard Magazine for their help with this episode. Daisy Egan, Theodore Ross, Brent Cunningham, and Tom Laskaway are Buzzkill's executive producers. Funding for this podcast is provided in part by the Band Foundation. And I'm Teresa Katsourelis.